Test predictions, fractions to decimals. Let's look at a fraction first of all. We might not work with that often. Let's take 1/99. 1 over 99. If we want to check what this number is in decimal form, we need to divide the top number, the numerator, by the bottom number, the denominator. So 99 goes into 1. Well, it doesn't go in, 99 doesn't go into 1, so we need to look at the next number along, which is in the tenths column. It still doesn't go in. You can't fit 99 into 10, if that's how we're going to think about this. So we need to bring down, or we need to look at the number in the hundredths column, which again is a 0. We could keep putting zeros in here, still number 1. And say that 99 into 100 goes once, which is 99. So we put, that's a 0, that's a 0, and that's a 1. 100 minus 99 is 1. So then we need to bring down the next number, which is a 0. 99s don't go into 10, so it's a 0 there. Bring down the next number, which is 100. 99s into 100 goes once, which is 1. And do the same thing where we subtract 99 from 100. We get 1. Bring down the next number, which is 0. 99s into 10 don't go. Bring down the next number, that's 100. Well, with the 0 to make it into 100, 99s into 100 goes once. Put 1 up there. You might begin to see a bit of a pattern now. 0.010101. I can tell you that this is carry on repeating this pattern forever. There's a quick way of writing this. If numbers repeat in a pattern like's happening in our example, we can just write 0.010. There's a couple of ways of showing these numbers repeat. We're going to use dots, so just put a dot over the two numbers that repeat in this case. So we know that 1/99 is equal to 0.010, and these two numbers here are recurring. So have a quick look at 2 over 99, see if that's any different. Well, we expect it to be different, but let's see if the pattern changes or whether we get a similar pattern. So 99, how many times does that go into 2? We'll put our zeros in after the decimal point. We're not changing the number, we're just writing it to more decimal places. 99 won't go into 2, it won't go into 20, but it will go into 200. So we put our 0.0 to represent the fact it won't, 99 doesn't go into 2 and it doesn't go into 20, but it does go into 200. And that is 2 times 99 is 198. So that's twice that 99 goes into 200. Subtract 198 from 200. Leaves 2. Bring down the next 2 zeros because we know we're going to have to do that. Because we brought down 2 zeros, we put down 1 0 to represent the fact that 99 won't go into 20. 99 goes into 200 twice, and that's 198 again. I think you might be able to see that we're going to have a similar pattern again. So 99 into 200 goes twice. Can say for certain now that the pattern is going to repeat again. So 1/99 is equal to 0.010, and the 1 and 0 recur. 2 over 99, 2/99 is equal to 0.020, where the 2 and the 0 recur. If we wanted to predict what, let's say, 27 over 99 was as a decimal, you might be able to look at these two results and make a prediction. You might notice that the numerator appears in the hundredths column in this case, and then it's followed by 0 in these cases, and then the two numbers that appear repeat. You might predict that because there's nothing in the tens column here, that this 0 represents the fact that there isn't any tens in the number that's at the top of the fraction. So that being the case, we'd know that the third number in the fraction 27/99, written as a decimal, would be a 7. We might predict that the 2 appears just after the decimal point, because 27/99 is a much bigger number than 1/99 or 2/99. So we might get a number here, and that would fit in with our prediction. So we might think, so our guess from the evidence might be that 27/99 is equal to 0.27, the 2 and 7 are recurring. We haven't quite got room to do our long division on this one, so let's see if we can bring up the calculator to do this one. 27 divided by 99 is 0.27 recurring. So from our test, we've managed to make a prediction, and looking at the calculator, it appears our prediction in this case is correct.